So this is my video 81. I'll start it with the next poem I wrote. Very short poem, the shortest one, only 68 lines, but the rhythm of this poem, the rhyme of this poem is kind of different from the rest of the stuff. Like, I always wrote the rhymes like 1 1 2 2, but somewhere in the Snow White I wrote like 1 2 1 2, and this particular poem, except for the first 4-line verse, it has the rhymes like 1 2 1 2. Let's go. The queen was dying of old age. Her plan had reached the final stage. She'd cause the demon lord's demise. She'd make her perfect sacrifice. There were no people in the hall to give the queen a glass of wine. The coward queen, as she was called, expected this. She didn't mind. She waited all these 80 years to wreak her vengeance on the Lord, withstanding the despising glares which wounded deeper than a sword. She was a traitor in their eyes, who had betrayed her faithful friends, who hadn't made her sacrifice, who had saved her own hide instead. The legends told the demon lord had just appeared out of nowhere about 100 years before. He'd plunged the world into despair. The five of them, the young pure girls, were destined to defeat the Lord. The prophets saw that dream of hers. The girls were chosen by the God. They should have paid a heavy price to free the people of the land. It was a perfect sacrifice which would ensure the demon's end. Each of her teammates gave their lives. Each of her teammates gave their lives for her to pass the demon gods. They started as a group of 5. One person reached the inner yard. But when she was alone to face the demon lord in his throne room, she chose dishonor and disgrace just to avoid her awful doom. She didn't make her sacrifice, she didn't kill the demon lord, she chose to be, what a surprise, the traitor of her own accord. She made a treaty with the Lord. She'd get the title of the queen of her own country and afford to live without concerns and spleen. Her subjects all despised the queen, the greatest coward in the world, the traitor of her faithful team, the prostitute paid by the Lord. But only she and her 4 friends, who died so many years ago, knew what the prophet really meant, assigning them those deathly roles. The perfect sacrifice to make, which would defeat the demon race, was not to sit upon the stakes or peel the skin off your own face, but just endure, to live your life of treachery and cowardice, not being loved as someone's wife, not going through a mother's bliss, and be this way until you died, and take your secret to your grave. That meant the perfect sacrifice, for all the peoples to be saved. She finally took her last breath and died. The smile was on her face. For years she had restrained her wrath. Her death wiped out the demon's race. Well, it was quite short, and I like the consistency of the rhyme, because it's really easy to expect 1 2 1 2 style all the time, or at least 1 1 2 2. But when I switched from one type of the rhymes to the other, it was kind of difficult even. It was difficult because I divided my poems into these 4-line verses. But for example, Comrade Pushkin, who wrote his poems switching from one type of the rhyme to the other type of the rhyme, he uses this plain text without dividing it into the parts. So there was no really the rhythm within the small verse, because it was one long poem. Anyway, now I'm going to switch back to my programming stuff, and I have 12 more scripts to reach the linked list scripts. And I'll start again with some specify function which takes a string and it returns a string. And I have the solution which includes only one line. First, I convert string into the array of characters by applying this array constructor. And then I use map over this array. Yeah. And I convert each character into the string, and then I join all these characters in the array with the separator space. Well, very simple, very understandable solution. Maybe it is possible to take string itself and map it and map its characters. Maybe I need to check this later, but for now I'm going to look at the the previous solution. Oh yeah, really? Yeah. I have this best practice, and it says that I can apply map function, map method, right to the string instead of going into this array, converting string into the array. Okay. And when I trained to use the start index and index while navigating through the string, I wrote the plain loop. Like, first I define index like the start index of the string. Then in the while loop I go, I change this index until I reach string and index. And in the last line of the loop shows how I can increment this index. I use index method over string, and this method takes two parameters. The first one is current index variable, and the second one is the offset. And I write one, which means I take the next index. This way I can take the index which falls under the, I can take each second index, each third index, yeah. But I need to go through all the characters in the array. That's why I increment index position, index offset by 1. Yeah, this index method of the string object returns index that I need. So what I do next? Using string, using this subscript over string, I get the character itself. I convert it into the string, and then I do this concatenation of the string that I get before plus this current character plus the space character. So it's quite understandable code. It's quite easy, but in any case, I need to read it from the beginning to the end, and it's really easy to get this particular functionality from the functional type programming, functional type of the programming. And in the end, I remove the last character, which will be the space in the end of the string, because I need only the spaces between the characters, not in the end of the string. It was a very quick, Swift script for the level 7. Next, we have a function man from boys. It takes the array of ints and it returns the array of ints. So, what we have here? I see that in the function we get man, something, some collection, and boys collection, and then we return the concatenation of these two collections, man plus boys. So no dubs, I think it's no duplicates mean. And we define the set of ints, the set which contains integers, yeah. And we get this set by using the constructor set over the array. So I think no duplicates means we don't have duplicates in this array. That's why we can, or in this, set guarantees that we don't have duplicates, because it just, I think, skips the duplicates from the array. Then we apply filter over this no-dubs set, and if the integer in this, if the element of the set is even, which means the remainder of the division by 2 equals to 0. So there is no remainder after division by 2. So all even integers are put into this man. Okay, it will be the array after we filter set. I'm not sure. We can get again this set, another set, but after applying sorted method to this set, we get the man array variable. The same stuff goes with the boys array, which contains only the odd elements of the set, and I used sorted method with the parameter, with explicit parameter, this parameter name, external parameter name by, and the sign is greater, which is default for the sorted method, but I just wanted to use this explicit stuff to show that I understand the how it works under the hood. So in the end, we concatenate man plus boy and boys arrays, And basically what we did here is the following stuff. There was an array of integers. It was an array of integers with duplicate elements, with duplicated elements, and we get all of the even elements, I mean all the even integers. We sort them in ascending order and put them in the beginning of the array. Then we got all of the odd integers without duplicates. Again, we sorted them, we arranged them in the ascended order and put them after the first part of the array. And we will just return the resulting array. Okay, I have something interesting. Circle of numbers. Int plus int and returns int. If first is less than n over 2, then we return first plus n over 2. Otherwise, we return first minus n over 2. I'm not sure what this is all about, but I have best practice which takes first plus n over 2 and returns the modular over n. Yeah, I don't know. This is some kind of shifting algorithm, and it's easier to understand it from the text of the task than from the code, because code is really concise in both cases, but I don't understand what was the original task. Sort of simple function to circle of numbers. I don't know what this task means, but now I have this very long function and I just need to read a lot for it. Decode resistor, maybe decode resistor colors. We have bands, which is a string, and we return string. In the end, we return something like number string ohms %. Let's see. The array of codes. The array of strings, each string is some code. Black, brown, red, orange, yellow, green, blue, violet, gray, white. Then we have these colors, which is the array we take the band's string and separate it by the spaces between the strings, and we get the array of colors from the parameter. Then we have some arithmetics. We get first index. We have first index of the first element of the colors, and we know that this first index, exists. So we use the force unwrapping operation. First index of the second element of the second string and the first index of the third string. So first digit, second digit, and power exponent, don't know. And we have tolerance. If colors count equals 4, then we say that tolerance equals the fourth element of this colors array. What do we do next? We perform some arithmetic operations like first digits multiplied by 10 plus second digit. It's like first digit shows the tens, and the second digit shows the ones. Yeah, like AB, like 53. The first digit is 5 and the second digit is 3. Then we multiply this by something like, we calculate the number 10 in the power to the power of some power expression, exponent maybe. Like if this power exponent is 2, then it will be 10 to the power of 2, which equals to 100. Yeah, and we get the number. Then we have some if-else stuff, like if number less than 1000, then string is just an empty. Yeah, we have this suffix to show the thousands and millions. Like we do nothing if the number less than 1000, but if the number is greater than 1000 but is less than 1 million, we use this k, a kilo suffix. And if the number is greater than 1 million, we use m suffix. Next, we calculate something like number string, which is number multiplied by 10 converted into the integer, and we calculate the remainder when we divide by 10. If there is no remainder, then what? What this thing is about? Okay, so we calculate number string as integer over the number. Yeah, then we say that number string will be the whole number. Otherwise, we use the number that we get as the double, for example. Oh yeah, so it was about calculating different parts of this returning this expression that we will returned expression. So now we calculate the percents. The initial value is 20. If the tolerance equals gold, then the percents equals 5. If the tolerance equals silver, then percents equals to 10. And in the end, we create this string which uses all these variables that we calculated during our algorithm. There is some best practice. It takes some names and uses the compact map method over these names, and in the end it I'm not sure what are the names, but this compact map applies colors first index colors first index over the elements of these names. So I don't understand what this all is about, but again, they use compact map, and it's a very useful feature. I need to learn how to use it as well. Okay, we have level 7 script, replace all items. It uses some generic function, the array, and okay, we have 3 parameters: the array of some generic type t, and 2 other parameters, old and new, of the same type t as well, and we return the array of type t, and this t should conform to equatable protocol, which means the variables of this type may be compared by some operations, whether they are equal or greater than or less than. What I did, I used array. I mapped the elements of the array with the closure if the first element of the array equals to old, then we replaced it with new. Otherwise we just returned the same item. So the idea was to find the generic function which replaces all the occurrences of one particular element in the array with some new element, and all the other elements should be should remain intact. So I have the initial solution which used map function as well, but I used the long form of writing the closure for this map method. So this closure takes one parameter lem of type t in the parentheses, and we have this arrow which points from the left to the right, and after this arrow we have t as the returned type of this closure, and in keyword shows the body of the closure, where I used yeah, this if-else operation. Okay, I did this just to remind myself how to write the parameters inside of the closure. Again, very short script. Printer error. It takes the string parameter. It returns string. It returns string. So what's going on? I return the whole string, and inside the string I use this inline calculations. We have s filter okay, we have this s filter over, we have this s filter over the string, and if the element is inside of the range from n to z elements, okay, if the element gets inside of this range, then I keep this element, otherwise I throw it away. In the end, I count the number of the elements which are in this range, which were filtered, and I calculated over. No, I don't calculate it. I write the string. The first part will be the number of the characters which are in this particular range, and the second number will be the number of all characters. And I have the best practice, which allows me to filter using comparison between the characters, like the one which I get from the string and m character, and m character without this contains everything stuff. So I can compare to elements like character and m character inside the filter function. That's kind of a good implementation, good feature of the language. Next we have partial word searching. The function word search takes string and the array of strings returns the array of strings. What do we do is we have the array. We go with the filter function, filter methods over this array, and each s string from this array is processed inside the body of the closure, like s lowercase. First we make all the letters, we turn all the letters to the lower register, and then we check whether this string contains the first parameter, which we lowercase as well, so that we don't bother about the size of the letters, like the capital letter or the small letter. So we filter only the strings which contains this string we put as the first character, put as the first parameter, and we return these strings in the array, or we return the array with the string empty if we don't have such strings in our array. Okay. Next is order than rest. Order means 1, 3, 5, and so on. So I have this function order 1 with the parameters array of ints, and it returns finally. For the first time I see the optional of int as the returning type. So we have the enumeration over the arrays, and we have the tuples like index and the array and the element itself. If the absolute value of this element, I'm not sure, maybe they have this functions like point odd, then if the absolute value of the element is odd, then we return the index of this element. Otherwise, we return nil, which means we don't have. So in the array we have only one odd number, or we don't have odd numbers at all. So we need to return optional, which shows the index of this odd number, or it doesn't show anything at all, like it shows nil. Quite a short solution, but I have some best practice and I'm going to check it. So first we get first index of first, really, we get the first, what was that, array, first index, and we have some condition that the element is odd. Okay, first I don't know, maybe first thing. So it can be done in just one line, like first index, the condition of this element, and this first index should return nil or the index itself. Or we have other lines, like we could use array enumerated in one line, like using first, which is the first element of this array of tuples, and this first element, wow, so first index and first could get the closures the same way filter could get this closure. Wow. So we could get through the tuples, which returned bool if tuple element, not the index part, tuple element was odd, and then we applied offset offset. Okay, yeah, we applied offset to get the index from this tuple. Quite a complicated solution, but it is understandable and it uses the features of Swift language. And the third solution was to filter this enumerated array. And again, if we needed to enumerate we needed to filter the tuple with the odd element, and then wow, they mapped this tuple into the offset. That's kind of funny. Yeah, that's an interesting approach, although it's not so cool as the first one, but it's kind of understandable in terms of this function style programming, and it shows the power of Swift. I have 4 more scripts. I'm not sure that I can get through all of them, but I will try. Numbers with digit inside what? So we have this int 64, two parameters of type int64, and we return the rev int64 type numbers. So what we have here, just kind of one string. The solution was written like one string, but I divided it into different lines to improve the readability of this solution. So we have the range from 1 up to x number. We map each number into the string. We filter we filter the resulting array like we have only we leave only the numbers, the strings, the numbers which contains one particular digit. And in the end, we map into the stuff into the array of integers. And there, in the end, I could use a compact map, I think, so that I could avoid this nil coalescing operator. No, so the solution takes 2 lines. The first line gets the numbers, and the second line calculates this return array, which consists of 3 elements. The first one is the count of all the numbers which contain this digit inside. We convert this count into int64 because we need to return the array of type int64. The next the next element of this array calculates the sum of all the resulting numbers in the array, and the third element shows that if the this array is empty, which means we don't have numbers containing this particular digit, then we return 0. Otherwise, we calculate the product of all these numbers. That's why int64 was used, because the resulting number will be too large for the int type to keep. And the best practice for this thing will be define numbers. Okay, we can skip this map. Yeah, really, we can skip this map into strings operation and go right into the filter where we can use this string conversion instead of doing some separate operation. And also we can use type alias, define our type lon for int64, so that we don't need to type this int64 all the time. Well, I think I'm alright with int64, it's not a big problem. Okay, we have some other function, moves in squared strings. There are three functions. We just defines. Okay, we defined three functions here in this particular script, like horizontal mirror, vertical mirror, and some operation. This operation takes the closure, or it takes maybe the function which with one parameter string and the returning type string, or maybe it's closure. I'm not sure how is the function which we pass in as a parameter is defined, and another parameter is a string, and in the end we return some string. And horizontal mirror takes string as, then I get the components of the string separated by the symbol of the new line, like /n. We reverse all this. We reverse the elements of this array. We reverse the array so that the first element will become the last, and the last element will become the first one. And we join this with the separator. We join this with the separator and the new lines /n. Again, for the vertical mirror operation, we have this stuff like we separate the string by the /n operator, /n character, the character of the beginning of a new line, of switching the character of going to the new line. Yeah, and then we map each element with the reversed one, and we can join all the elements with the separator, which is the character of going to the next line. Yeah, and the third function operator will use these two defined horizontal mirror and vertical mirror functions as the first parameter, and it will apply this function to the second parameter. And I can check the best solutions for this particular task, and they are about I have this as split separator /n, and the comment says that it returns array of substrings. Maybe it means that as component separation returns something different than the array of substrings. Maybe it returns the array of some components, substrings, I don't know. But anyway, then components separated by /n map component in component, I mean each character, each element in string, in component reversed, okay, and converted into the string again. Or the short version takes the component, reverse it. Wow. So yeah. Oh no. Map, string. Well, actually, I did the same stuff. The only difference is that I don't have joined separator /n in the end. I don't know why. But actually, when I checked the best practice with my own solution, they are identical. Yeah, they're really identical. So I don't see any advantages, any benefits to use this best practice over my solution. Okay. And with this, I think I'll stop. I'll stop with commenting my Swift scripts, because I already have only two random scripts to comment, and I have 4 linked list scripts to comment. That's why I will leave this for my next session, and I think the next time I will cover all the rest of the scripts. I think for now it was alright, because it's really difficult to think and speak English at the same time, or even it's more difficult to think over all of these scripts, to think aloud. Even in Russian, it will be quite difficult to explain the meaning of the scripts just by reading them and commenting all the stuff without reading them like silently, and then commenting what I had there. Anyway, I think I have more than 50 minutes of recording, and that's all right for me. That's all right for one particular session of practicing English, of practicing thinking in English, or even commenting programming style, programming stuff in English. So that's all for today's video 81.